Hello everyone. This is going to be our second algebra lesson. Building off of what we just talked about, this is going to be about operations with rational and irrational numbers. If you forgot about what a rational or an irrational number is, you should check out the previous video, which was lesson 1, to refresh your memory. So if you're watching this video, I'm going to assume that you know what a rational and an irrational number is. So let's jump into it. So rational numbers, we remember, were numbers that can be written as a fraction where the numerator and denominator are integers. So really, since elementary school and middle school, you've only been working with rational numbers. And what happens, if you decide that you want to add two rational numbers together, subtract two rational numbers, multiply two rational numbers, or divide two rational numbers, the outcome is always rational. I mean, just one quick example. Let's say a rational number is 1/2 plus, let's say, 2. If you can't do this in your head, you can use a calculator, of course, but this is 3/2. So this is a rational number. This is a rational number. When you add them, you still get a rational number. Okay? It gets a little iffy when we're talking about two irrational numbers. Okay? The exceptions I'm actually going to write over here. So generally, I can say this many times, generally, the outcome is going to be irrational. Okay? However, there are exceptions. Okay? Sometimes it's not. So you know what? I take back what I said. I completely take back what I said. Let's write this instead. It depends. Okay? Depends. Okay. Usually, the outcome is irrational. However, there are some exceptions. Okay, so except, I can't spell, exceptions. Okay? So, for example, we know the square root of 3 is irrational because this is not a perfect square. What if I subtract that by the square root of 3? Are these both irrational numbers? Yes. The operation I'm using is minus. Well, what's the outcome? Well, when I subtract anything from itself, you always get 0. But you know that that's rational. Okay? So this is one exception. Another exception could be, and you'll notice this really deals with when we're talking about like square roots of numbers. Let's use this cool purple color. What if I did the square root of 5 times the square root of 5? Well, if you don't know how square roots work or radicals work, you can always use your calculator. But very quickly, the way we can do this, 5 times 5, since we're multiplying, we can multiply the inside. So 5 times 5 is 25. And the square root of 25 is 5. So the outcome is also rational. One more example. What if I did the square root of 3? You know what? No, I take that back. What if I said the square root of 8 divided by the square root of 8? Well, anything divided by itself is 1. So this is also rational. So normally when we do use operations between irrational and irrational numbers, it usually is an irrational number. However, sometimes it's not. So I'll be honest, the best way to do this is put it as a little star, put it on your calculator. Okay? If you put it on your calculator, for example, if you saw this, oh, that's a big circle, sorry. If you did this and you're like, huh, that's probably going to be irrational, just put it on your calculator. You'll see this, and you will definitely know that this number is rational. Similarly, if you did the square root of 5 times the square root of 5, and you put that on your calculator, you would get 5, and you would say, oh, well, I know this number is rational. Okay, so when in doubt, put it on your calculator, see what you get. For rational and irrational numbers, the answer is also, it depends. It depends. Okay. Let's switch up some colors. Now, usually, it's irrational. Okay. But there are exceptions. Okay. There are exceptions. So, let's talk about some of those exceptions. What if I said pi, which we know is an irrational number, it's 3.14159, so on and so forth, times 0. Well, this is an irrational number. 0 is rational, but we know 0 times anything is 0. So this number is also rational. Or what if we did, let's think of another type of number. Just another number. What if we did the square root of 12? No, I lied. What if I said 0 divided by the square root of 12? So do you remember what happens when you do 0 divided by anything? Well, it's also 0, which is also rational. So I'm going to highlight this. When in doubt, put it on your calculator. Because if you don't remember these rules, then you're going just to assume, oh, irrational times, or anything to do with another irrational is going to be irrational. Or irrational and an irrational always gives you irrational, which is not always the case. So why don't we do some examples together? And of course, these are all Regents questions, so we know exactly what we're going to be dealing with. So Jacob is working on his math homework. That's great. He decides that the sum of the expression 1/3 plus 6 times the square root of 5 divided by 7 must be rational because it's a fraction. Is Jacob correct? So I'm going to quickly use my problem-solving planner. I'm not going to write out all of it. I'm just going to try to annotate this. Oh, it's lagging. I'm just going to try to annotate this question. So we need to know if Jacob is correct, and we need to explain our reasoning. Well, let's see. He says that the sum of this expression, which is this, must be rational because it's a fraction. Well, that should remind us, well, he's thinking that rational numbers can be written as fractions where the numerator and denominator are what? Integers. Well, let's rewrite this expression. So we have 1/3 plus 6 times the square root of 5 divided by 7. Well, this number you should be able to identify as a rational number. Okay. Now, check this out. You ready for this? This is a fraction, right? Fractions that have numerator and denominator as integers are rational. Well, let's see if this fraction has integer, numerator, and denominators. Well, the denominator, this is definitely a rational number. But what about over here? 6 times the square root of 5. Well, the square root of 5 is irrational, 6 is rational, and when you multiply them together, you still get an irrational number. Okay? Let's break this down even further. An irrational divided by a rational, well, that's going to be irrational. So we're left with this. A rational plus an irrational. And if we go back to our previous screen, we really didn't have any exceptions for that. But if you really wanted to, you could put this on your calculator and you'll see it's going to be clearly an irrational number. And really the main answer that you want to write, because it does say explain, a rational plus P-L-U-S plus an irrational number is irrational. Oops, R-A-T, my bad. R-I-R. You must always end with a smiley face. Okay, let's do another one. State whether 7 minus the square root of 2 is rational or irrational. Explain your reasoning. Well, 7 is rational. The square root of 2 is irrational. Literally the same reasoning. Let me see if I can just select this. Awesome. Check this out. Boom. Oh no. Ah, no. There you go. Same reasoning. Also, if you decide to put this on your calculator, actually, I'll do it right now for you. I have my calculator right next to me. So 7 minus the square root of 2. If you put that on your calculator, that equals 5.5858786, so on and so forth. Could you guess what the next number is? Absolutely not. There's no pattern. Irrational. Let's do another one. The product. Remember, product means multiply. The product of the square root of 576 and 684 is... Well, why don't we figure it out before we even look at the answers? The square root of 576... Now, you might not know this, but if you put this on your calculator, the square root of 576 is 24. And the square root of 684... And I'll put this on my calculator so that we can have the exact numbers. The square root of 684 is 26.1533 936, so on and so forth. That's a rational number. This is irrational. So when I look at my answer choices, there has to be irrational and irrational. So, number 1, I'll put it in red. The product must... Oh, sorry. Let's actually go back. If we're multiplying these two, right? If we're multiplying, we know the answer is going to be irrational. Because irrational times an irrational, in most cases, is irrational. So that means it can't be number 2, can't be number 4. Okay? Number 1 says it must be irrational because both factors, so both of these things, are irrational. Well, we know that's not true because this one's rational. Can't be this one. Answer must be 3. Last but not least, this is a very common question on the Regents. So let's kind of do this one together. Which of the expressions result in an irrational number? Well, why don't we, actually let's make this a little bit bigger, why don't we just identify each of these terms? So, if we look at number 1, these are two fractions. Both fractions have integer, numerator, and denominator. So this is a rational number. Number 3, you might say to yourself, oh, this is irrational and this is irrational. But this is actually the exception. If you multiply the square root of 5 times the square root of 5, your answer is 5. So this is also rational. Okay? This is a fraction, which means that this is rational, plus the square root of 2, which we know is irrational. So number 2 is irrational. Also, if you put it on your calculator, 1/2 times 1/2 plus the square root of 2 is going to be a decimal number that goes on forever with no pattern. Okay? And this one, well, you might say to yourself, oh, there's another square root, but remember, you have to check if this square root is a perfect square. And if you don't know, use your calculator. The square root of 49 is 7. 7 times 3 is 21, which means that this one is a rational number. So which expression results in an irrational number? It's just number 2. I hope this helps. Please make sure you subscribe so you see the other videos that myself and Miss James will be posting in the near future. I hope this really does help. If you have any questions, please leave in the comments down below, and enjoy the rest of your day. See you later.